Chapter 5, Section 6 is about graphing these inequalities that we've been working with this chapter, but dealing with them as like a linear equation. So you're going to have two variables. You're going to have like an x and a y. I want to kind of go over some basics of graphing just to kind of bring that back from what we've done in previous chapters. Remember with graphing that if you had an equation that looked like y equals 2/3 x plus 2, this would be considered in slope-intercept form, and there'd be two like main things that you need to be able to pull. The slope, which is always in front of your x, and the y-intercept, which is always in front of, or at the end of the equation. So like that would be your b. And in order to graph a line like this, we would start at 2 on the y-axis, because that's what the b means. That's your y-intercept, so that's where it crosses the y-axis at. So you'd go up 2 and draw a point. And then your slope would be that 2/3, which is the rise over the run. So that tells you how much up and down and how much left and right you go. And since they're both positive, we would go up 2 and right 3 to get another point. And then we would connect and get our line in there. Okay? We're going to do the same thing in this section. It's just that instead of having an equal sign, you're going to have an inequality sign. And so we'll talk about how do you handle that? Like how do you decide, what your line should look like? And we'll talk about like shading, because like on a number line in the previous sections, we had to shade, a specific direction depending on what kind of inequality sign we have. And so the same thing happens here with these graphs. We'll have to talk about how we're going to shade. Now there might be times that you have to rewrite an equation, so they may not give it to you in slope-intercept form. So when you're doing these steps, the first thing that you'll want to do is see if you need to solve for y. So do you need to rewrite the equation so that you get it in that slope-intercept form? So you really want it to be kind of back in that y equals mx plus b. It's just you won't have an equal sign. This will be an inequality sign instead. So it'll be less than, greater than, less than, equal to, greater than, equal to. Then after you've got it rewritten so that it's in that form, you'll want to check that inequality sign. So if it's just a less than or a greater than sign, that'll tell you that it's going to be dashed, which means that any of the points that are on your line are not actually going to be part of the solution set. So if you don't have an equal sign with your inequality sign, when you go to connect your dots on your graph, you're not going to do a solid line, you're going to do a dashed line. Then, if it does have an equal sign, you would have it be a solid line like normal, because that would mean that all the points on the line are going to be included in the solution set. So you'll want to check that after you've got it solved and you're trying to graph it. Then you graph your line, and then we'll talk about how to shade the appropriate side of the line. We'll talk about testing a point that's not on the line. I'm just going to put a note here that most of the time we use 0, 0. We use 0, 0 because it's an easy point. It's easy to calculate with 0, especially if you're multiplying or dividing. So it's a good point to use. The only time that you can't use 0, 0 is if your graph goes through the origin. So if it happens to go through 0, 0, we'd have to pick a different point that isn't that one and then test it. But most of the time 0, 0 will work. We plug that point into our inequality to see if it's true or false, and then that will tell you what side of the line you should shade on. If it comes out to be a true statement when you put 0, 0 in, then you want to shade on that side of the line that 0, 0 would belong on. If it's false, then you want to shade on the opposite side. Let's take a look at this example so you can see exactly how this is going to work. For this first one here, they don't have it written in slope-intercept form. We've got 2x minus 3y is greater than 15. So the first thing I need to do is actually solve for y. I need to rewrite this. So you've done this before when you were solving equations, like if you were written in point slope form or if you were written in standard form and we had to get it in slope-intercept form. You've done this work before. You have to solve for y. You have to get that y term by itself. So the first thing that they did down here is they subtracted that 2x. So that's why they wrote that negative 3y, because that's what would be left. Brought down the greater than sign. Now they put the negative 2x first because remember we're trying to get in this form, y equals mx plus b. Just no equal sign. We've got a greater than sign instead. So negative 3y is greater than, that negative 2x goes first, because that's the mx piece, and then plus 15 goes after that. Now we'd still need to get y by itself. It has that negative 3 sitting in the front. So what I did next is I divide everything by a negative 3. Now you can do that kind of individually like I'm doing right here, or they wrote it down here as just like one big step. Just make sure that you know when you're dividing by that negative 3 that you are dividing every single term by negative 3. And that's how they end up with this equation down here. Because on the y, the negative 3 over negative 3 is gone. So they got y left. Now notice how your sign switched to less than. And that's because we divided by a negative number. So those rules still apply. Now in the x piece, we had negative 2 over negative 3. Well, negative over negative becomes positive. So they just wrote it as positive 2/3 x. And they left it as a fraction because I couldn't divide that very nicely. And then last we took 15 divided by negative 3, which would have been negative 5, which is why they have minus 5 written here. So now that we have our equation written in this form, now we're going to graph it. So to graph this one, your y-intercept, or your b, your starting point, is at negative 5. So from 0, 0, you go down 5. Then you use your slope, 2 over 3. So from negative 5, you're going to go up 2 and right 3. And remember, you can do this as many times as you'd like. Now we need to figure out how we're going to graph it. Like, are we going to have a solid line or a dotted line? And then we need to talk about shading. What side of the line do we shade on? My inequality sign that I have circled here is just a less than sign, no equal sign. So you need to have a dotted line. So when you go to connect these points, don't be too quick to just draw a straight line through them. You need to draw a dashed line through those points. So now we need to talk about how to shade. Like I said, I like to pick point 0, 0 if I can. It's not going through the origin, so I should be able to use this point. What I do is I put 0, 0 in for the x and in for the y in this inequality that I have here, that I just graphed. So I put a 0 in for y, less than 2/3 times 0, and then minus 5. If I simplify this here, this is 0, less than, this is gone, because 2/3 times 0 would just be 0, and I have negative 5. So you have to ask yourself, is 0 less than negative 5? Well, no, it's not. 0 would not be smaller than a negative. So this is false, which means that we do not want to include 0, 0 in our shading. So we want to shade on the other side of the line where 0, 0 is not, which would be down here. And when I shade, I just kind of take my pencil, or if you have like a highlighter that you want to use, or sometimes students will use like a colored pen or a colored pencil, you just kind of color on that side of the line, just enough so I can kind of see that this is the area that you're shading on. So we've got a couple of practice problems here. What I want you to do is pause the video, try to do this practice problem, and then when you're ready to see how it should have worked out, go ahead and keep watching it and I'll walk through it. So the first thing you need to do on this practice problem is solve for y. So I'm going to start by subtracting x. So I have 5y less than or equal to, I put the x first, so it's negative x, and then plus 10. And then we divide by 5. I divided by a positive, so I don't need to worry about switching my sign. I rewrite the x because it's like a negative 1 over 5, so I just write that as negative 1 over 5x, and then 10 divided by 5 would be 2. So there's my equation. Now I'm going to go ahead and graph it. So I go up 2, and draw my first point, and then I use my slope, negative 1 over 5. So from that point I went down 1, right 5, This time my line should have been solid because this does have an equal sign. And then for shading, I need to test a point 0, 0. And I can still use that point because my graph does not go through 0, 0. So I put a 0 in for y and a 0 in for x. When I simplify that, I have 0 is less than or equal to 2, which is true because 0 is smaller than 2. So this time when I shade, I want to include 0, 0, which means I need to shade where 0, 0 would be at, which is underneath the line. Okay, if you got that right all by yourself, then you should be feeling pretty good that you kind of understand the concept. If maybe you got part of the way there or you made a small mistake, hopefully now you can kind of see what you did. And I want you guys to try again if you need to try to fix anything here. Now this one's a little bit different than the last one because they don't have a y. Okay, so this is kind of an odd problem. It's not like the other ones that we saw. What I would want you to do on this one is solve for x. So the first thing I would do is subtract 7. So we'd have 4x is greater than 16. Then we divide by 4. And so we have x is greater than 4. Okay, now how do we graph this? You remember when we had something that was an x value, x equaled a number. You go on the x-axis over to 4, and you would draw a straight up and down line. So over 1, 2, 3, 4 to the right, this would be where 4 is at, and you would draw a straight up and down line through that point. Be careful on this one though, because it doesn't have an equal sign, so it's not going to be a solid line here, it's actually going to be a dashed line. Okay? Now let's talk about shading. This is saying that x needs to be bigger than 4. That's what that inequality says there. So anything greater than 4, or even think about like this as that number line. 4 is on the number line here if I'm going left and right. And I want greater than 4, which would be everything to the right. So when I shade, I need to shade everything over here. You could still test 0, 0. You could put 0 in for x. You would end up having just 0 is greater than 4, which is true. Sorry, not true, false. And then that's why we're shading on the right side, because we don't want to include 0, 0 in our shading. Okay, this next example here. You have $100 to buy school clothes. Shirts are averaging $17 and jeans are averaging $25. You have some of each in your closet, and we want to figure out how many each we can buy. So I've got this know, don't know chart filled out just so we can kind of maybe organize our thoughts a little bit here before we try to get to the problem. Okay, so for this one, I know that I have $100 to spend, which means that I can spend $100 or anything less than that, but I can't go over the $100. So I would write that as I can spend like less than or equal to 100. I can't go over that amount because I don't have any more money than that. I know that shirts are $17 and jeans are about $25. What I don't know is like the number of shirts that I can buy. So let's call that S. And I don't know the number of jeans I can buy. So let's call that J. And you could use other letters if you wanted to. So what we need to do is create equations to represent this situation. So I'm going to buy jeans and shirts. Okay. Now I don't know like how many of each, but I just know that their cost. So for shirts, it's 17. So for however many shirts I buy, I need to spend $17. So an easy way to write that would be 17S. That way, if I bought 2 shirts, 3 shirts, 4 shirts, I could just take it times 17 to figure out my total cost. So for jeans, we're going to add that on. I would write that as 25J. This has to be less than or equal to 100 because I can't spend more than that. I'm going to think of S as like my X and J is going to be like my Y. So I'm going to go ahead and solve for J on this equation. To do that, we would have subtracted 17S first. So we'd have 25J is less than or equal to negative 17S plus 100. And then I'm going to divide by 25. Again, I'm going to divide everything by 25. So my equation is going to say, not Y, J is less than or equal to, I'm going to leave this as a fraction, negative 17 over 25 S plus 4. Now I need to graph it. Now for the graph, I might need to change my scale just so that I can fit my numbers on here a little bit better. So what I'm going to do is have my y-axis go by 2's and have my x-axis go by 5's. So for the 4, for my starting point, I need to go up 2, 4, and draw my first point. And then for the next one here, I need to go down 17 and over 25. So down 2, 4, 6, 8, 10, 12, 14, 16, 17, and then over 25. So 5, 10, 15, 20, 25 would be right there. And then I'm going to draw my line, connecting my dots here. Let's try that again. Now, they want me to like shade on the area of the graph. Now, we're talking about spending money here. So like really anything in like these quadrants here are probably not going to be valid numbers because that would be like me buying a negative amount of shirts, a negative amount of pants, and spending a negative amount of money, which I'm not going to do. So if I think about testing a point like 0, 0, if I put that in, I'd have 0 is less than or equal to 4, which is true. That means that really the solutions I'm looking at are going to be like in this little triangle that I made down here. So I'm just going to shade that in. This is where my solutions are going to be. Because anything in there is going to be a valid number of shirts and a valid number of pants, and it's going to be $100 or less that I spent on it. So on the next page here, there's a practice problem. And I want you to pause the video, try to write out your equation and graph it here, and see if you can figure this one out. Okay, so what I would have done is written out an equation first. How I started it is I did 12p for the pies, $12 for a pie, and then I added that to 8c for the dozen cookies. And I need to raise $200 at least, but I could always raise more than that. More would be great. So greater than or equal to 200. I solved for c, so I subtracted 12p. So I had 8c greater than or equal to negative 12p plus 200. And then I divided everything by 8. When I did that then, I had c is greater than or equal to. Now negative 12 over 8 can't divide perfectly, but it can reduce. So I reduced it to negative 3 over 2. So I took a 4 out of both. P. And then 200 divided by 8 is 25. Then I needed to graph it. I had my y-axis go by 5s. So I went up 5, 10, 15, 20, 25. And then I went down 3, so I'm not going down quite a full square. And then I went over 2. And you could do that again, like down 3 over 2. You know what? When I go down 3, I can actually still just go over 2 full, because I didn't change my x coordinate, or my x-axis. And then I could go down 3 again and go over 2 more. So, solid line, because I have an equal sign with my inequality. And then we needed to test a point, like 0, 0. If I do that, I have 0 is greater than or equal to 25, which is false. So I don't want to include 0, 0, which means I want to shade over here. Okay? Now they want you to give 2 examples that would work for like the number of pies and the number of cookies that we could sell. So what I would do is pick like 2 points out here. Maybe pick this one, and let's pick this one. So where I just put those X's at. And let's count. So down on here, we just went by 1. So I went over 1, 2, 3, and I went up 5, 10, 15, 20, 25. So I went over 3, and I went up 25. Now, my C, like that's what I'm pretending to be the Y right now. So that would be my dozen cookies. So I would need to sell 3 pies. And, what did I say? 5, 10, 15, 20, 25 dozen cookies. There would be 1 solution. And for this other one that I put over here, that's going over 1, 2, 3, 4, 5, 6. So I could sell 6 pies. And that's going up 5, 10, 15, 20, 25, 30, 35 dozen cookies. Granted, there's tons of other solutions out there because anything in that green area is going to work. So you didn't have to pick those 2. You could pick any 2 points that you see out there in that shaded region and just kind of count over on your graph to figure out how many pies that's representing and how many dozen cookies that's representing.